We have a quiz coming up a week from today. I think that sounds right. That's what I said we were gonna do, so I will get a study guide to you. There are a couple of topics on that study guide that we will be covering. I think it's. I realize I've made a mistake with one thing completely unrelated to this class at the moment. So we have no class on Monday. Tuesday, we have a guest speaker. Wednesday, we have the client demo. So we don't really meet in a capacity between now and then. And we also don't really meet in a capacity where we can have a discussion about what's going to be on that quiz. So I actually might end up moving it to the following Monday, depending on, there's one more thing that I'd like to have covered. I want to cover a bit of CICD before we take that quiz. So I'll get back to you on that. If I release a study guide or I'll think about it, I'll make an announcement of some kind. It's either going to be next Thursday or the following Monday, depending on if we cover one.
We record the like.
Yes. Yes, absolutely. If you happen to be available during that time, I don't know what that's going to look like. You could zoom in so you could ask questions.
If it's on Thursday, we're gonna be on.
Yeah, no worries.
That would be funny though.
Yeah, the lecture will be on Tuesday. The guest lecture will be on Tuesday. I'll be recording that for sure.
In person.
Yeah, in person on Tuesday. Perfect. So yeah, if the quiz is one of those days, you get back. No sense. Is there anything else? Any concerns? Any questions? Before we get started on a little bit more content. Hey. So last we were talking about test-driven design. And so we talked about some of the benefits of this, that we got some instant feedback. There were some better development practices that could lead you to more than making up for the time that it takes to write the tests first by finding some tests, finding some cases later on. Talked about QA. The fact that you have those up-to-date tests means that you know that your program is capable of whatever those tests can test at any point in time because you already wrote the tests. Lower rework effort when something goes wrong, you can identify based on the tests, you know exactly where to go look and find those issues. Because the tests target very small elements and you write the tests small piece by small piece. See, some limitations, hard to learn. It's really hard to justify for novice programmers actually going and doing that. It's certainly difficult in certain situations. It doesn't include an upfront design. So you need to think about the design before you write the tests for it, because otherwise you will have to rewrite the tests after you finalize the design. So the test should be written after the design is fully finalized. We said it's tough to write test cases for hard to test code. There's certainly some code that is a bit on the harder side to test. And then we said that final limitation was if we're looking at a waterfall-like process, even if it is an iterative waterfall or an extreme waterfall, we blur the phases of that development because testing is supposed to happen after development in that world. Could have some pros, could have some cons. So let's take a look at a survey. This is not the world's highest sample size survey. 24 programmers. But these who have been in the field for at least 5 years. So looking at the productivity, they were asked about, are you more productive in a TDD versus non-TDD environment? 78% said that they were more productive in a TDD environment. Are the requirements better if you're thinking about the testing beforehand, are the requirements clearer? And 88% agreed the requirements were clearer if you went from that process directly into TDD. Debugging effort, the amount of time and energy that it takes to debug. That was almost all of them. 23 out of 24 programmers said debugging was easier in a TDD environment. Total development time was perfectly split. Some said development time was shorter under TDD, and some said that it was not. The aggregate effectiveness, how effective was the overall result? 80% said they had a more effective product at the end of a development cycle with TDD. Higher code quality, 92% agreed that the code improves if you go through a TDD process. Simpler design, 79% said if you design and write the tests first, then you get a simpler design. Is it noticeably effective? 71% said, yes, I can feel the differences between development and TDD. Difficulties in the adoption, 40% said, yes, we had difficulties in the adoption of TDD. It was difficult to program in that way and to think about getting into that mindset. 56% said it was difficult to get into that mindset. Is the lack of an upfront design a hindrance? Only 23% agreed with that. Most said that was fine. It was still okay to start writing the tests ahead. So part of the Sprint 3 requirements from my perspective as the product manager is that we need to agree to adhere to test-driven design. So what I'm expecting to see comes from looking at the tests and looking at the final product. Did you write the tests for the product that's in front of you, or did you write the product in front of you based on tests that you had written? I will be able to see that difference. Yes.
For those of us who are doing a lot with factory, what is that?
Before you change up and implement, so you can write tests without the associated code. So you can even be in the process of just thinking about what features need to be present. What does the final code look like? What is the final code going to be able to do? And just an input to output level. It doesn't matter what the guts of the code are. You can write the test that says, give this function this input. The output that I expect from that is this. Great, that's a test. You will then write the code that test will call that method to actually convert that input to that output. But you've thought through what that output should be. So for something like testing undo redo, you don't have to have the code complete, but you could go through a unit test that says, create class C1, create class C2, undo, redo, undo, create class C3, delete class C1, undo. You can come up with a sequence of calls. There's probably a bunch of different tests, but you would have the create a class, undo it.
So are we
Test.
okay to get the
Yes.
and then we can do the test?
Yeah. So if you want to finish kind of the Sprint 2 requirements refactoring for Sprint 3, that's okay. Whenever you have new functionality, you want to write the tests for that functionality and then move from that to the actual implementation that's going to pass that test. All of the tests that you write should fail the first time you run them because you haven't implemented the code to pass the test yet. So there's an agreeing to. Can I get that verbally from every group? Raise your hand if you agree to work in TDD for this sprint. At least try it out. Again, there's no guarantee that it produces something that you are going to be happy with the first time that it happens.
We hold the power here, don't agree. Don't agree. We all don't agree, you can't make us do it.
Let me put it this way. It's on the rubric as frequently used TDD. So I'm getting everyone's okay that says that they are now aware of what that
Come
means.
on.
And it's something we're gonna try out
In the
for.
spirit of election week came.
How many points is it? Is the question I should ask?
It's part of something that's worth either 10 or 15 points, but it's part of 10 points.
Okay, so it's.
We got
It's just the part that is it's embedded in, what was the other category? What was the category it's embedded in? I feel like the very bottom.
In the testing category.
Yeah, test category. So the test that you write, part of the credit for the tests is they were written before. Yeah. We've talked plenty about design. So again, these are not two of the same. You're not choosing task-driven development or behavior-driven design. We've been using behavior-driven design the entire course. So behavior-driven design creates the design based on the intended behavior. So we're considering the behavior of the final application before we even start the development of it. As we are working on the development, we are always going back to the drawing board of, is this doing the behavior that was specified at the beginning? So this is part of user stories or part of behavior-driven design. This means that we're just focusing on that abstracted, client-focused behavior rather than actually how the code is to be written. So this is where we bring in what we talked about at other places in the course. We have business value. So discover the business value of this behavior, or don't worry about how to implement that particular behavior. Every behavior that your application can do should have relevant business value. So for instance, I am not calling this team out by any means, but I want to use this as an example for everybody else. So in sprint one of the teams came to the client with a login screen. And this was not a feature that had been asked for by the client. The way that I think that you would discover that this functionality is not a necessary part of the project right now is that what is the associated business value of that decision? Is the client able to, is it part of the usability from the client's perspective?
Security should always be thought of for the programs.
I completely agree with that. But in an application that is meant to be launched from the command line and does not connect to anything, we need to log in.
Yet.
Yes, sure. But when that feature becomes relevant or has business value, then you can put that into the application at that point in that sprint when that is defined. So that's just an example of something that would tie to this business value relevance. But it's something that you can always ask about every single user story that you write. Is this something that drives the business value of this application? And then moving from user stories to acceptance tests, this is all part of behavior-driven design. So we can automatically map the user stories directly to decide if the client can accept the app. How do we match the English text of these user stories to the tests that we write for the test code? Could we run the tests without someone in the loop in this process to perform the actions of the tests? That is the direction we are heading next, because running tests is a huge pain. We would like to be able to write some tests, integrate some tests into our application, and then just forget that they are there until they fail. As soon as they fail, the tests are relevant again. But we shouldn't ever have to worry about running our tests again. Wouldn't it be great if we could just automatically know all of the time, are any of our running tests failing? Because then you're not just writing tests to have to use those tests, you're writing tests that become guarantees about the behavior of your app. And that becomes a very big deal. Not a ton of super relevance right here, but the idea is that if you write comprehensive tests that address all of the needed behavior from those user stories, then you could say, I have implemented the behavior from those user stories because my program passes all of these tests. So how do you know, based on the tests that you've written, that you've guaranteed that behavior? If there are an infinite number of possible inputs, you can't write an infinite number of tests. So this is where some kind of logic that says if this test passes, then all of these other tests will pass. That may be based on white box, the exact nature of the code, to say there are only 2 different paths through this code. I've tested both of those paths with a relevant value. If it succeeds for one value, based on this logic, it will succeed for all values. Sometimes you can say between bounds. If it succeeds for this value, it'll succeed for all values between this lower end and this upper end. Or for this particular data type. So you need to have reasoning behind that. That reasoning can be logical, but it can also be mathematical. So we'll talk a little bit about this concept of formal verification and how can you formally verify your code in a couple of weeks. So we go from a user story. What is the acceptance criteria directly from this user story? So user says, as a driver, I want the vehicle to determine the speed limit and set the speed to that limit so that I do not have to pay attention to speed limits. If you were to write tests regarding this, what would those tests look like? To basically say, if these tests pass, then the software that I have written implements this user story. This doesn't have to be an exact unit test, but what would those criteria be? How could you phrase a statement that said, if this statement is true, then we have met this criteria? Doesn't just have to be one statement, but yeah.
Looking at the components, you gotta check that the software can grab that and parse out what the speed limit is. It can set the speed limit and then maintain the speed limit and continuously check to make sure it's at the correct limit.
Yes. So I think you're mixing white box and black box, and that is all relevant information. But splitting that out between what aspects of the code, can we look at the behavior kind of in a black box setting, regardless of what the implementation is? Behavior-driven design says, rather than look at the implementation, let's just look at the results. What would the results look like of a test?
No fatalities, actually follows the speed limit.
Yeah.
Results,
Yes. So we could measure that when we implement this software, if the car maintains a speed close to the speed limit, but not exceeding the speed limit by some measure of what close to the speed limit is, then great, that would be an acceptance criteria. That's one way to just overarching say, is this doing what it's supposed to? So if it ever exceeds the speed limit, it's not doing what it's supposed to. If it is driving significantly slower than a speed limit for no reason other than it's deciding to do that right now, that would also be considered a failure. But the acceptance criteria is if our program does this, then it works.
What's our confidence interval for this speed?
Close to, plus or minus 4C.
I'm gonna have to see your T-star values on this.
So we could also convert into a scenario, right? we would say something like from here, given a speed limit, when the car drives, then it is close to but not above the speed limit. This is an untestable scenario because it is ambiguous. If we rewrote it to be an acceptance test, now we would actually have something that could succeed or fail. What would we need to do to get this scenario to a point where it could succeed or fail? Yeah, so this is an ambiguous test. You can't, it has ambiguous wording. Close to but not above the speed limit. How can we make this a testable acceptance test, something that could actually fail, rather than have some interpretation as to whether it succeeded or failed? Yeah, I put some mathematical value in here. We need to define what that means. Plus or minus 2 miles per hour. I guess just minus, we don't want to exceed the speed limit. Minus, we put in 3 miles per hour, 5 miles per hour. We need some way to ensure that the implementation is in balance. Yeah.
I might be overthinking this, but I feel like another thing you might want to consider as a secondary variable is acceleration rate. For example,
Sure.
say you're wanting to go onto the highway where you're getting off. It's like, oh, 70 miles, okay, now I have to go down to 35 miles per hour. Suddenly brakes like full stop,
Yeah.
like flat through the windshield.
Sure. In terms of usability, absolutely. So if this was the only user story that you got from your talking to the client, that's probably shows that you want to communicate more with your client. How many G's would you like to experience?
I hope you don't want a good drive safe and save score, because this will not give you that. You need to improve on your braking.
So here is what an acceptance test would look like. Given the speed limit is 50 miles per hour, when the car drives, then its speed is between 49 and 50 miles per hour. This is now testable.
Yeah.
Obviously, there are additional constraints that we should be considering if this is actually in traffic. Is there someone in front of you? You don't want to be going 49 and 50 miles per hour if the person in front of you is stopped.
Yeah. Is it like an emergency situation? There are a lot of ones.
Yeah, see, there's a lot more happening here. But the idea is this acceptance test is now something that your program needs to be able to do. If it doesn't, then you have not fulfilled your contractual obligation. So you can map something like a user story directly to an acceptance test. So we went directly from this user story. As a driver, I want the vehicle to determine the speed limit and set the speed to that limit so that I do not have to pay attention to speed limits. That became this acceptance test. Not the only acceptance test, but it is a test that would need to pass in order for the software to be viable. Now we can write additional acceptance tests that get to the braking issue that we were just talking about. Given the speed limit is 50 miles per hour, when the speed limit changes to 30 miles per hour, then the deceleration rate should be less than 5 feet per second squared. That is another acceptance test that could be written before you write any code. Just by talking to the client, you could determine that this is an appropriate deceleration rate for hard brake based on just a speed limit change. Not based on what's in front of you, but just based on when the speed limit changes. How do we handle deceleration? So the idea is that we want to be doing this before any code implementation. If you use the scenario format that we've been talking about, then it becomes very easy to convert these into acceptance tests, write those acceptance tests, and you can contractually sign off on a set of acceptance tests. if I write an application that passes all of these acceptance tests, do you agree to pay me this much money? It's probably a good idea to draft all of that before you start implementing. We all know that we want those contractual terms in place before we do any real work. Otherwise, we can waste that real work. So here's something else that I want to kind of pose to the class. Imagine writing an auto grader for a lab that you've experienced in the past. For those of you who have had me for 300, you can imagine writing an auto grader for the linked lists that are singly, doubly, or circular, for instance, to figure out, do these sort themselves appropriately? Do they, all of the tests that you could do with that. But what about an auto grader for that to determine if the sorting has been done correctly, if the linked lists add correctly, if the linked lists, we have as input some program, we want to determine whether it meets the associated specifications. So we could write acceptance tests that say, if this program passes all of these acceptance tests, then it gets 100% of its score. If it passes 95% of the tests, then it gets a 90%. If it passes, it doesn't matter what the rest of the rules are, you could write a behavior-driven design auto grader that says, based on, here are the tests that need to pass if this program is to work. If this particular test does not pass, then provide this level of feedback based on the diff between the output that's expected and the output that this program produced. You can give custom feedback to students who have absolutely no idea how this auto grader works. So they just submit a program, their behavior of that program is analyzed, and then it returns a custom set of feedback based on whether it succeeds or fails at those acceptance tests. So that's exactly what happened at my last institution, as well as what I'm trying to bring to this institution. So as some of you probably know, I'm in the process of trying to get an auto grader online for 210 and 211, and preferably a lot of other courses as well. But the idea is that you can write them as scenarios. So here's an example from, I believe this was from data structures at that institution. So the scenario is that the copy constructor works. When we copy construct an empty array, then the state is properly initialized. So this is a scenario for that. We can write the test with the message the capacity is incorrect because we can directly look at the associated test line in a testing file, run that test, with an explanation that creates an expansion of the terms of what it's supposed to have, require that the capacity is 0 after we copy an empty array in a copy constructor. The feedback that you would get then is the capacity is incorrect for this. So you can write behavior-driven tests like this with a file of tests. You attach that to a lab, and now every submission runs all of those tests to determine the functionality of that. So that's what we're trying to get online. You can imagine that would be pretty useful in those classes. I'm not particularly happy with how those classes run right now. A lot of us have had that individual conversation, but we can apply this to our own institution and everything that you've been doing. If any of you move on to be master's students here and want GSAs to make tuition free and pay you some money, then one of the tasks you can do with that would be to write some labs for some of these courses and write some tests for some of these courses that would allow us to switch out and choose from a bunch of different labs for a lot of these early courses. So very useful to be able to write tests for anything. Kind of a summary of everything we've talked about so far. Studies are inconsistent, both with regards to the quality of code produced under test-driven design and the productivity that happens with teams that adhere to test-driven design. It's something that you should have experience with because in industry, your company may require you to use test-driven design. That should not necessarily be something that you fight against, but it should be something that you have experience with going in. You'll know how you, the programmer, interface with this design. Questions before we move on to our next topic? Right. We're going to do a very brief set of slides on code coverage. And then we will move into talking about continuous integration and how we are going to get continuous integration online for Sprint 4. So what is code coverage? We need ways to figure out how much of our code has tests written for it. Sometimes that can be enough to tell us when is our code tested enough, over-tested. So in general, code coverage is just the percentage of our code that has automated tests written for it. This is not just tests anymore, but they're tests that run whenever something happens. We'll talk about how to do this with continuous integration. So how do we measure code coverage? There are a bunch of different ways that we can choose to measure code coverage. One would be to count the number of statements in the code body that are executed over a given test run. So we have 87 tests. And after running all 87 of those tests, they hit 64% of the lines of code that are in our program. We would say we have 64% statement coverage. You could also count the statements not executed in a test run, and you just have a ratio or a quotient of the number of tests run over the total number of statements, or the total number of tests, the total number of statements run versus the number of statements that were not run. Of course, some statements are going to be more important than others, but it's difficult to measure in code coverage. It's difficult to identify which are the really important lines of code that need to have tests written for them to ensure that they work versus others that either are very infrequently run or just don't matter as much to the results of our program. So why care to measure code coverage? Why would we care to know what that value is? As we develop tests, we need to figure out when do we stop. If you have that code coverage, you can get things like green highlights or yellow highlights or red highlights that tell you green says every possible branch through here has been tested. Yellow says some branches that hit this, but not every branch that hits this has been tested. And red says you have no test that runs this line of code. So you can see at a glance, where are the weaknesses in your testing? What lines of code do we not know if they work correctly or not? When we want to write more tests, you can just take a look at that code coverage report, look for some important highlighted red or yellow areas, and develop some tests that don't have overlap with existing tests to be able to turn some of those lines green and say we've written some tests for that coverage. Keep in mind that even if that line is green, that doesn't mean we've tested it for every single possible input. Green just means that some test was written for that line of code. Maybe that test had an input of the number 500 when we should test something that's negative, test something that's 0, test something that's not a number, test something not expected at all. There may be many tests that you want to write for that. So code coverage is a little bit less useful for that. The concept of target coverage just says that we want there to be some number of total lines of code that we want to have a test written for. So if your coverage level is 90%, that's a 90% of the statements in my code have a test written for them. Note that it's easy to make that code coverage hit 90% if you write garbage tests that are meant to pass and not meant to reveal bugs. So we talked in our testing about writing tests with the purpose of revealing bugs. It's useless to hit an arbitrary threshold if you're just writing useless tests. That is work for no gain. That is useless. That is a waste of everyone's time. Instead, it should be used as a way of saying what hasn't had a test written for it. We should at least think about the best tests that we could write to reveal potential bugs over that. The idea of some target coverage is if you are writing the best tests that you can, you would agree that we have about this much development time to focus on writing tests. So maybe we have, I don't know, a total of 40 person hours that we could reasonably use to develop the tests. We would anticipate as the project manager that maybe we could get to 90% coverage of the model with a total of 40 person hours. So then I would set the requirement as we need 90% code coverage over the entirety of all of the classes in the model part of our code. Of course, writing those tests, you want them to be useful rather than just check a box. So why write unit tests to automatically test your code? Think about this in an interview setting. This is something that it can somewhat frequently come up in interviews. How well do your unit tests actually test your code? How could you identify in a unit test, does this significantly test my code or not? Difficult questions. How many tests are enough? We know that we can't prove that a program is bug-free through writing unit tests for it. We're just never going to be able to use all of those inputs. So when can we be sure enough? At any point in time, do we need more tests? Should we be writing more tests? There's this concept called test entropy that is basically the value of the next test that you would write. The longer it's been since you wrote those tests, the less useful those tests are within the scope of the now web of complexity of the code. So it could be worth going back and rewriting some of the tests to better reveal bugs with the complexities of the system. There's also another idea that every test that you write becomes less and less useful if you are perfectly able to identify the most important tests early on. Eventually, you've written enough tests to where the time that it takes to write the next test is not worth the time that it would take to write that test. The chance that it reveals a new bug is so slim that it's not worth taking the development time or effort to write that test. In an ideal world, that's where you stop writing tests. But knowing when you're there is an obfuscated problem that no one really knows. So taking a good guess and knowing about when that is going to be would be useful in an interview setting. Let's say you're writing some code. Rather than have you write the tests, an interviewer might ask you to tell me about the tests that you would deem to be appropriate for this functionality. And then they would look at how many tests do you come up with? What level of functionality do you find to be important enough? And are you generating tests that are no longer worth the time and effort and energy to create them? Are you making too many tests? There's a sweet spot in the middle there they will be looking for. So things that code coverage can do. As our code coverage increases, it becomes more and more difficult to write more tests. The tests that we write cover less vital portions of the code. I just mentioned this, but we get that trade-off between writing additional tests and actually completing the project. You could just write tests forever, but then we never have a working product. So again, it makes sense that there's a middle ground there, that we want to complete the project, but we want to make sure that the project is the best project that we could create given our time constraints. So it does rarely make sense for code coverage to be 100%. Code coverage doesn't fix everything. It doesn't take the place of doing code reviews. It doesn't take the place of knowing how to write good code. So knowing what the coverage target should be is something that you will learn from experience. How could we measure code coverage? We talked about statement coverage, but there are 3 general ways to find that level of code coverage. So we will add statements to the source code in source code instrumentation that are going to be compiled along with the code. That produces the code coverage information at compilation. So when we compile our program, we are also analyzing to see how many lines of code are run by the associated tests. There's intermediate code instrumentation that says after we compile the classes themselves, then we add the logic after that. We will generate a new class after we get the compiled class file that then incorporates the code coverage. So we compile the source and the testing back to back. We can also look at runtime information collection. So as the program is executing, it's going to run all of the tests. And then it's going to make use of and check, for each of these lines, did they ever get hit by those tests? So that's an execution environment that we call runtime information collection. So those are the 3 different ways that you can measure code coverage. You could write an application that would give you that value. Everything we have said so far has been statement coverage, but there are 2 other types of code coverage that we might care to measure. The first one is branch coverage or decision coverage. Rather than looking at the lines of code within a branching statement, we're going to just look at the number of branches that got tested. So if we have a large switch statement with 12 branches, if we write tests for 8 of those possible branches, then we would have 8 out of 12, 66.66, etc. % branch coverage on that branch. So how many branches are tested? If you have Booleans in the control structure to true that are evaluating true and false, then that makes sense. We end up with branches of size 2, size 2, size 2, size 2, especially if you have embedded statements. Or an if statement, inside an if statement, you have a method call. Inside of a method call, it can return true or false. When that happens, you branch from the return, and it can become arbitrarily complicated to figure out the branch coverage of a particular point in your code. There's also method coverage, and that says during the execution of any of the tests that you wrote, do we enter that method? And it's mostly useful for things like error cases. Maybe you have a method that handles particular program behavior, and method coverage will say, did you write tests that ensure that the code that you wrote that handles its breaking does what it's supposed to? Any questions about code coverage, coverage types, how we could measure it, why that's important to consider? All right, well, this is basically the end of this really short set of slides, which is perfectly timed, right on the end of class. So we will leave it for the weekend. don't come on Monday, you'll be alone. Or if you're not alone, you can have a nice laugh with everyone else who's here.
A really good chance in the show if you're on the.
2 years, those late, I got held back, and I went to the family, my train got canceled like 3 times. And I went to work on New Year's, no one was there, and they came over. And I said, literally finally, they're like, you can't change your staff, and then you know, student hired me, and they got bought out by different people. You can't put your bucket and blanket, then you can. You know, I'm student, you know, I can't do that.
Remember as well.
Oh, yeah.
1 second. Remember that we have a variance, and we like your, I say, we want to hear.
Well, I